Imagine you are the CEO of a major publicly traded company. You wake up one morning, grab your coffee, check your phone, and the internet is just completely exploding.
Always a great way to start the day.
Oh, exactly. A total nightmare.
Yeah.
Because there is a video of you, flawlessly generated, announcing your resignation and confessing to embezzling millions of dollars.
And obviously, you didn't do it.
Right. You know it's a fake. Your family knows it's a fake. But then the forensic analysts come in, and they look at the video's metadata, they check the network writing logs, the entire digital footprint, and all the traditional software indicators say the file is authentic.
Which is absolutely terrifying.
It is wild. You are standing there telling the truth, but the digital reality entirely contradicts you. So, how do you mathematically prove you didn't do it?
How do you prove your reality is the actual reality?
Yes. Because we're all living in this era of incredibly sophisticated data manipulation, and honestly, it's just a total erosion of digital trust.
It's an exhausting, really paranoid way to navigate the world.
It really is. For years, we've relied on traditional cybersecurity to protect us. We put up software firewalls, create complex passwords.
And just kind of cross our fingers and hope the perimeter holds.
Right. Which, at this point, feels increasingly like using a screen door on a submarine.
That is exactly what it is. I mean, we are generating and consuming more data than at any point in human history, right?
Yeah.
Yet our confidence in the authenticity of that data has never been lower.
Yeah.
We've basically been trying to solve a fundamental truth problem with, Band-Aid security patches.
Right, because traditional security architectures are entirely perimeter-based.
Exactly. They build a wall around a house. But if a bad actor gets inside the house, or if they, spoof the credentials to just walk through the front door,
They can do whatever they want.
they can alter the internal records at will. The system just assumes that whatever is inside the perimeter is trustworthy.
And that brings us to the core mission of today's deep dive. We are looking at a source that completely flips the script on how we handle digital truth.
Oh, this source is fascinating.
It's an article published on March 30th, 2026 by Maurizio Rizzari, and he details something called Hyperbound 1.2 and the SYRAG trust paradigm shift.
A lot of buzzwords in there, but the concept is massive.
Yeah, massive. We are exploring a monumental industry pivot here, moving away from the old concept of security, where we constantly ask people to just trust the firewall,
Right.
and moving toward what he calls native verification, where we actually prove the truth mathematically. For you listening, this is basically your shortcut to understanding the absolute cutting edge of how we will define reality online.
And look, I know terms like Hyperbound 1.2 or cryptographic state can sound, intensely technical on the surface.
Oh, completely. It sounds like science fiction.
But the underlying philosophy here is actually profoundly simple, and it is absolutely essential for anyone trying to navigate today's information overload.
Okay, let's unpack this, starting with the foundation. Because before we can trust any piece of data, we have to know exactly where it came from.
Right, provenance is everything.
Exactly. And the fundamental problem with software is that it's malleable, it can be tricked, it can be spoofed.
Very easily.
So Rizzari's article introduces this three-tier binding concept to solve this. And the very first tier is hardware identity, or FP binding.
Which bridges the digital record directly to the physical world.
Wait, okay, tell me about the FP part. That stands for fingerprint, right?
Yes, FP stands for fingerprint. And in this context, the protocol leverages the literal physical fingerprint of the hardware's silicon.
The literal silicon.
The literal silicon. Because when microchips are manufactured, the silicon structure develops these microscopic, entirely random imperfections.
Oh, wow.
Yeah. No two chips are physically identical at the atomic level.
That makes sense.
So every single digital operation in the Hyperbound protocol is anchored to those unique physical components of the machine it is actually running on.
Okay, I love this. It's like the microscopic wood grain of a piece of timber.
That's a great way to think about it.
Like no two pieces of wood have the exact same grain pattern, right?
Yeah.
You cannot manufacture a perfectly identical replica of a specific oak board.
Exactly.
So Hyperbound is looking at the microscopic wood grain of the silicon chip itself. It reads those unique physical imperfections and uses them to generate an unforgeable cryptographic identity.
Yep. It binds the data to the machine.
Like a wax seal stamped by a signet ring that is literally fused to a specific person's hand. You can't copy the seal because you need the physical ring to make the mark.
That's a perfect analogy. And if the data doesn't come from a machine with that exact specific physical silicon grain,
The data is instantly rejected.
rejected. You can't just spin up a fake, unauthorized shadow system on a cloud server somewhere and, pretend to be the real source.
That is brilliant.
What's really fascinating here is that we are entirely removing the gap between the physical hardware and the digital output.
Removing the gap, what do you mean by that?
Well, in traditional cybersecurity, that gap, the space between the physical server and the software running on top of it, is the exact vulnerability where the most sophisticated data manipulation occurs.
Oh, because that's where the hackers slip in?
Exactly. Bad actors slip into that space, they hijack the software and make it output whatever they want, completely divorced from the physical reality of the machine.
But with this, you can't do that.
Right. By binding the identity to the silicon itself, Hyperbound 1.2 essentially welds the software to the hardware. The origin of the data is a physical reality, not just a line of code.
Okay, so the machine is physically authentic, but wait, let me push back for a second.
Sure.
What if I just inject malware into the RAM while the machine is actively running? Like, the silicon is real, sure, but the software process has been hijacked midstream.
That's the million-dollar question. Because securing the hardware is only step one.
Right.
We need to know the software process itself remains pure from start to finish. And Rosari introduces the second tier to address that exact vulnerability: system integrity monitoring.
System integrity monitoring. How strict is that?
Incredibly strict.
Mm-hmm.
The entire digital environment is continuously scanned against a known cryptographic state.
Okay, so it knows what normal looks like.
Exactly. The system establishes a perfect, mathematically defined baseline of what the operating environment should look like when it's completely secure.
Got it.
And the monitoring system constantly checks the live environment against that mathematical baseline.
Okay, but the article says, and it really stood out to me, it states that if even a single configuration bit is altered without authorization, the Hyperbound protocol immediately isolates the process.
Yep. Full shutdown to stop the data stream from being contaminated.
Okay, I have to play devil's advocate here. Shutting down a whole process over a single bit of data being changed, that seems completely unworkable in the real world.
How so?
Well, bit flips happen naturally all the time, right? Due to cosmic rays, minor hardware degradation, or thermal fluctuations. Are you telling me an entire multi-million-dollar pharmaceutical trial gets scrapped because a random cosmic ray hit the server and flipped a 0 to a 1?
No. We have to distinguish between standard hardware errors and unauthorized changes to the cryptographic state.
Okay, explain the difference.
Modern servers already use error-correcting code, or ECC memory, to catch and fix random cosmic ray bit flips at the hardware level. Those natural anomalies are resolved before they ever impact the logic of the software.
Oh, so the system handles the natural stuff quietly.
Exactly. Hyperbound is looking at the cryptographic hash of the execution environment.
Ah, I see.
If a malicious actor injects a tiny piece of code like a single unauthorized instruction into the memory space to alter the outcome of that pharmaceutical trial,
That changes the math.
it fundamentally alters the cryptographic state of the environment. The system detects that the mathematical baseline has been violated, and it triggers a zero-tolerance lockdown.
Wow. Okay, so what does this all mean for the data we already have, like the historical record?
That's where it gets even better.
Because if a system is that aggressively guarded against contamination in the present moment, how does that affect the data we look back on months or years later?
It completely redefines how we view historical data, because alongside this continuous integrity monitoring, Hyperbound generates an operational chain of custody.
Through that thing they call the booted, right?
Yes, every single session generates a unique, cryptographically signed booted.
Which basically creates a perfect, time-stamped audit trail from the very moment data is ingested to the final analysis.
Exactly. Think about legacy systems. If a bad actor gains high-level access, what do?
They cover their tracks.
Right. They go backward, they alter past logs, change old financial data sets, rewrite history to manipulate a narrative.
But they can't do that here.
Not with a strict booted chain. You cannot retroactively alter the record. Every action is signed, time-stamped, and mathematically linked to the action that occurred immediately before it.
So if someone tries to meddle with an old file,
If you try to go back and change a single line in a file from a week ago, it breaks the cryptographic chain of custody for everything that happened after that exact moment.
The math just breaks.
The manipulation is instantly mathematically exposed. The system's extreme sensitivity to unauthorized state changes guarantees the purity of the entire historical record.
That is wild. It makes historical revisionism technically impossible.
Absolutely impossible.
It's like a continuous, unbroken camera shot of a room. If there is even a microsecond of a cut in the footage, you immediately know the scene has been tampered with.
Exactly. You can't just seamlessly edit a new person into the room without breaking the continuous shot.
Okay, so we have a perfectly secure local system now. We've bound it to the physical silicon, and we have an unbreakable, continuously monitored software chain of custody. The local data is pure.
It is. But now the challenge shifts.
Right. How do we prove that security to the rest of the world?
This is the ultimate paradox.
Because, okay, how do you prove your data is legitimate to an outside party like an auditor or the public without handing over your private proprietary information?
It's a huge problem for corporations.
If I am a high-level R&D firm, I want the world to know my breakthrough data is real. But I definitely do not want to hand over my raw, top-secret files so everyone can double-check my math.
It is the classic tension between transparency and privacy. Traditional systems usually force a compromise.
You have to pick one.
Right. You either keep the data secret and ask regulators to simply trust your internal audits.
Which people hate doing.
Or you make the data public so independent third parties can verify it, sacrificing your intellectual property in the process.
Which companies hate doing.
Exactly. But SYRAG solves this through a concept called hybrid anchoring. It projects local certainty onto the global stage without exposing the underlying data.
Here's where it gets really interesting because it uses tools we usually associate with completely different applications. Let's break down the two halves of hybrid anchoring.
Let's do it.
Starting with IPFS, or the Interplanetary File System, Rosari calls this decentralized persistence.
Right.
By utilizing IPFS, content is addressed by its unique CID, its content identifier. So the data transforms from just a file sitting on a vulnerable server into an immutable object.
To understand the leap forward here, consider how the internet normally works. Traditional data retrieval is location-based.
You go to a specific website address.
You type in a URL to access a specific address on a specific server to find a file.
Right.
But if a government or a malicious actor hacks that server and subtly alters the file, say, tweaking the numbers in a climate report.
The URL stays exactly the same.
Yes. You go to the same address, but you are unknowingly downloading corrupted data. IPFS changes that paradigm entirely. It addresses data by what it is, not where it lives.
The best way to visualize this is an ISBN library. Usually we find books by their physical location. Aisle 4, shelf B.
Okay, I like that.
If someone sneaks in and replaces the real encyclopedia on shelf B with a fake encyclopedia full of misinformation,
the next person just picks up the fake book.
Exactly, without realizing it. But IPFS is like asking for a book strictly by its ISBN number, a unique mathematical fingerprint of the text itself.
You don't care what shelf it's on.
Right. You only care that the content matches the exact fingerprint you requested. And that CID, the content identifier, is that mathematical ISBN. Or, honestly, think of it like a puzzle.
A puzzle.
Yeah. Imagine a puzzle where the GPS coordinates to find it are made entirely out of the shapes of the actual puzzle pieces.
Oh, that's good.
If someone changes even one piece, the coordinates change entirely, and the tampered puzzle simply vanishes from that address.
That is exactly how the CID works. If even a single comma in that digital file is altered, the entire CID changes. The mathematical fingerprint is completely transformed.
So you can't be tricked.
Right. If you request the original CID, the tampered file will not be returned. The link to the corrupted data is inherently broken. It provides self-evident, undeniable proof of interference.
You always know you're getting the exact file you requested.
Always. Now, SYRAG takes this immutable storage mechanism and combines it with the second half of hybrid anchoring, public accountability via Bitcoin.
Ooh, okay. Using a protocol called open timestamps, or OTS. And we need to be very clear here for the listener. We are not talking about Bitcoin, the volatile currency, or trading tokens on an exchange.
No, not at all. We are focusing purely on the Bitcoin time chain, the underlying blockchain infrastructure itself.
Right.
Because it is the most secure, decentralized, immutable computing network on the planet, secured by massive amounts of global computational power.
And the SYRAG protocol basically uses this network as an incorruptible public notary.
Exactly.
But wait, how does that protect privacy? If you're putting your data onto a public, decentralized ledger that anyone in the world can download and read.
Haven't you just handed your top-secret research to your competitors?
Yeah.
This is the brilliance of open timestamps and cryptographic hashing, because you do not upload your actual files to the Bitcoin time chain.
Oh, you do?
No. Your proprietary data remains completely private. It stays entirely on your secure, local, FP-bound hardware.
Okay, so what goes on the blockchain?
The Hyperbound system runs your private data through a mathematical algorithm called a hash function. It takes your massive data file and crunches it down into a tiny unique string of letters and numbers.
Just a small string.
Right. That tiny string, the hash, is the cryptographic proof. And it is impossible to reverse engineer the hash to figure out what the original data was.
Ah, I see.
You take that tiny, meaningless-looking hash, and you anchor that to the public Bitcoin time chain using open timestamps.
That is so clever. You're basically pinning a mathematical receipt to a global public bulletin board.
Exactly.
Yeah.
The receipt doesn't say what you bought. It doesn't list your trade secrets.
It just proves that a specific, immutable piece of data existed in an exact state at an exact, verifiable time.
Yes. It provides decentralized third-party proof of existence. And you get this proof without needing to trust a central authority like a government notary or a massive tech corporation or an auditing firm.
The math does it for you.
The mathematics and the decentralized network provide the verification.
Yeah.
And honestly, this raises an important question, perhaps the most critical theme of Rizari's entire article.
What's that?
It's regarding the definition of the word trustless.
Yeah, Rizari makes a huge point of redefining that term. He states the ultimate goal of Hyperbound 1.2 and the SYRAG paradigm is to create a trustless environment.
Right. And in everyday conversation, if we describe a situation as trustless, it carries a negative connotation.
Like it's sketchy.
Exactly. It implies a shady environment where we cannot trust the system or the people involved. But in cryptography and within the SYRAG ecosystem, trustless is the highest possible standard of security.
Because it means you don't have to trust the system.
Precisely. You are completely freed from relying on human fallibility, corporate promises, or the hope that a server hasn't been quietly breached.
You rely entirely on verifiable mathematical proof.
The architecture itself provides the indisputable evidence.
There's a line from the source material that distills this perfectly. He writes, "You don't ask the world to trust your word. You provide them with a cryptographic proof of existence that anyone can verify independently."
It is a complete inversion of how we operate today.
It really is. I mean, whether you're managing critical power grid infrastructure, publishing media, or conducting high-level corporate audit,
You no longer have to beg your audience or your stakeholders to believe your narrative.
you hand them the math. You hand them the CID and the open timestamps receipt, and they can verify the absolute truth of the data for themselves.
If we connect this to the bigger picture, it's the evolution from security to verifiable truth.
Okay, I like that distinction.
Security focuses on building taller walls and deeper moats to keep bad actors away from the data. Verifiable truth focuses on making the data itself self-authenticating.
So it doesn't matter if the walls fall down.
It doesn't matter if the perimeter is breached. The truth remains mathematically intact, immutable, and provable to anyone in the world.
Wow. Let's bring all of this together. We started this deep dive exploring the scenario of a fabricated CEO resignation video, right?
The overwhelming anxiety of deepfakes.
And the total erosion of digital trust. But what Maurizio Rizari and the SYRAG ecosystem are outlining is a future where we stop working harder to figure out who is lying.
And instead fundamentally change the architecture of digital truth.
Right. By binding the software directly to the microscopic physical silicon fingerprint of the hardware.
By instantly isolating any process that suffers an unauthorized change to its cryptographic state.
And by anchoring a private mathematical proof to a public decentralized ledger, we are building an immutable core.
The future is moving rapidly toward a standard where proof of existence entirely replaces, take my word for it.
And the ripple effects of this shift will disrupt every single industry that relies on the integrity of data.
It removes the heavy burden of trust from the consumer or the auditor, and it places the burden of mathematically verifiable proof firmly on the creator of the data.
Which honestly leaves us with a pretty massive philosophical question to ponder as we wrap up.
Oh, definitely.
If systems like Hyperbound 1.2 successfully replace human trust with mathematical verification on a global scale, how is that going to change human behavior?
That is the real question.
If our machines, our corporate networks, our media guarantee absolute, mathematically verifiable truth, what happens to the social contracts we've relied on for centuries?
Will a completely trustless digital world make us more trusting of each other in the real world?
Right, or will it make us fundamentally incapable of human trust because our brains will become so deeply conditioned to demand cryptographic proof for every single interaction?
The double-edged sword.
It really is. We might finally solve the problem of digital manipulation, but you have to wonder how living in a perfectly sealed, mathematically verified reality is going to change the human beings operating inside it.
Something to think about.
Definitely. Well, thank you for joining us on this deep dive. You are now armed with the insights to spot the future of digital truth long before it goes mainstream. Keep questioning, keep learning, and we will catch you next time.